Hello everyone. In this video, let's discuss how to implement stack using queues. Implement a last in first out stack using only two queues. The implemented stack should support all the functions of a normal stack: push, top, pop and empty. Implement the myStack class. Void push, we will have an argument called x, that is an integer type, pushes element x to the top of the stack. Into pop removes the element on the top of the stack and returns it. Into top returns the element on the top of the stack. Boolean empty returns true if the stack is empty, false otherwise. Notes: you must use only standard operations of a queue, which means that only push to back, peek or pop from front, size and is empty operations are valid. Depending on your language, the queue may not be supported natively. You may simulate a queue using a list or DQ, that is double-ended queue, as long as you use only a queue standard operations. Let's take an example. So here we have given the instruction as myStack, so we will not pass any argument and the output is null. And when I give the instruction as push, I have to give an integer value as input. I'll be inserting this 1 and then I'll have null as my output. Similarly, when I go for push, I have to insert 2, null as my output. I have given top, so which is the topmost element of the stack, 2 will be the topmost element of the stack, so 2 is the output. And when I give pop, so that element 2 will be pop and that will be returned as the value, so 2 has been printed as output. Then empty, checking whether stack is empty or not, so we'll have the element called 1, so it will not be empty, so it will return false. So we have to implement stack using queues. So we have two queues, using those two queues we have to implement the stack concept. Let's discuss the logic in detail. First we'll take two queues. Let me take two queues. Parallelly I'll write the code for this. Okay. So here we have to take two queues. So queue, I'm going to say integer value, integer q1 equal to, that's all, let me declare like this. And then second queue, q integer q2. I'll be taking two more variables, into top to find the top element of the stack, and I have to return the deleted element, right? Further I'll be taking one more variable called del. Now let me define my stack constructor. So public myStack. So here we have to allocate memory for the queue which we have declared. So q1 is equal to new linked list. Similarly, q2 equal to new linked list. Then I'll be taking one more variable called top. So top value I'll initialize as 0. And then I'll close the constructor here. Now we have to insert the element inside the stack by using queue. So for that I'll be taking public void push int x. So here to insert the element into the stack by using queue, we have a method called add. Through that we will add the value, and whatever the value which we are adding at the last, that should be the topmost element of the stack. So whenever we are adding the element into the stack, that value will be stored in the variable top, because the currently inserted element will be the topmost element of the stack. So that will be stored in a variable called top, and then I have to insert the element inside my queue. So q1 dot add x. So I have inserted the element inside my queue. Fine. So let's take a variable called 1. I have to insert inside my queue. So this is q1, this is q2. So first I'll insert the value 1 inside my queue. I have inserted. I am going to insert one more element called 2. So I'll insert, because when I go for insertion inside my queue, insertion will be happening at the rear end, deletion will be happens at the front end. So I'll be inserting one more element called 3 inside my queue. So 3 will be inserted like this. So this is how I'll insert. But this should be done with the help of queue for the concept of stack. When we go for deletion, you can find it. So here, when I delete an element, so which element should be deleted? If it is queue, 1 will be deleted, but we are going to implement stack by using queue. So 3 has to be deleted. We have to delete 3. So let's see how to delete 3 here. Let's go for the method of pop. Public int pop. So here whenever you're deleting, you have to return the deleted element. So for that, what I have to do is I have to take a while loop and I have to check one condition that q1 is not empty. So I'll give not of q1 dot is empty. If q1 is not empty, at that point of time, what I have to do is, if the condition is true, I'll take the element from the queue and I'll delete that. That value will be stored in a variable called del. So q1 dot remove. Okay, which means I will be removing 1. So 1 will be stored in a variable called del. So in the variable del, I have stored a value called 1. So in the variable top, what I have stored? At last, the value stored in top is 3 because that is the last element I have inserted. Now I have stored the value 1 inside the variable called del. After that, I have to check one condition. So what is the condition I have to check is, if q1 is not empty. If q1 is not empty, what I have to do is, I have to add that particular element inside q2. So here q1 is not empty. This I have removed. That I have stored in a variable called del. That value will be stored in a variable, and I have to check a condition saying that if q1 is not empty, I have to store the value 1 in q2. So that will be inserted inside q2. Repeat the process. So here check q1 is not empty. Yes, q1 is not empty. Remove the front element of the queue. 2 will be removed. That will be stored in a variable called del. And check the condition that q1 is not empty. Yes, q1 is not empty. If q1 is not empty, the deleted element 2 has to be inserted inside my q2. So I have inserted inside my q2. Now I will go for the next iteration of the while loop. Check q1 is not empty. Yes, q1 is not empty. If q1 is not empty, what I have to do? I have to take the element from the queue. Okay, I'll delete the element 3. That has to be stored in a variable called del. After that, check q1 is not empty. Actually, q1 is empty. If q1 is not empty, I can insert q2. Actually, q1 is empty. I don't want to insert inside q2. I have deleted the top element of the stack that has been stored in a variable called del. I'll come out of the while loop. Now what I have to do? I have to insert whatever the elements that is present in q2 back to q1. For that, I have to take a while loop saying that if q2 is not empty, what I have to do? I have to delete the element from q2 that has to be stored in q1. So that value I'll store it in top. So top equal to q2 dot remove. So I'll remove 1. That will be stored in a variable called top. That value I'll be inserting inside q1. q1 dot add top value I'll be inserting. Finally, I'll close the while loop and then I'll close the method. So this 1 will be inserted in q1. Now I'll check the condition. q2 is not empty. Yes, q2 is not empty. If q2 is not empty, delete the element from q2. Store it in a variable called top. After that, add that value inside q1. I have inserted. That's all. Check q2 is not empty. Actually, q2 is empty. I'll come out of the loop. I don't want to do anything. That's all. Finally, I have to return the variable called del, because in that variable only we have stored the element which we have deleted. So 3 is the one which we have deleted, right? Yes. So we have written 3 whenever we are deleting. Now what I am going to do is, I am going to find topmost element of the stack. So for that I have written a method. So public int top. So it is pretty simple. I have to return the variable called top. Return top. That's all. So in the variable top, I have got the topmost element of the stack. So in the stack, according to the stack, 2 is the topmost element of the stack. So I'll return the value called 2. Now I have to check whether my stack is empty or not. How can I know? I am going to take a method. It has to return true or false. So I'll take boolean empty. Return q1 dot is empty. If q1 is empty, it stays the stack is empty. If q1 is not empty, it stays the stack is not empty. So all these operations are done with the help of queues only. We are implementing stack concept by using 2 queues. This is the logic. Now let's go for the implementation of the program. So we'll declare 2 queues. Q, I'm going to say integer q1. q, integer q2. So I have declared two queues, and I'm going to declare two variables, int top, int del. I have taken two variables. Now I have to allocate memory for those two queue. q1 equal to new linked list, q2 equal to new linked list, and then I'll initialize a variable called top as 0. Done. I'm going to take a method called push. So here what I'm going to do, whatever the values I'm going to insert, that I'll be storing in a variable called the top, and then q1 dot add x. I have inserted the element inside my stack with the help of q. Okay. Now what I'm going to do, I have to delete. For that I have to check a condition. While if q1 is not empty, what I have to do, I have to delete the element from the queue. So q1 dot remove. That variable will be stored in the variable called del, and then I have to check one more condition, that if q1 is not empty, I have to add it in q2. That's all. I repeat the process until q1 becomes empty, and then take one more while loop, check a condition saying that q2 is not empty. If q2 is not empty, delete the element from the queue, store it in the variable called top. So q2 dot remove, the deleted element has to be inserted inside q1. So q1 dot add top. Done. Finally return the variable called del. This is the method for pop. Now I have to find the topmost element of the stack. Return the variable called top. Return top. That's all. Now I want to know whether my stack is empty or not empty. So here I have to check one condition, that return q1 dot is empty. If q1 is not empty, stack is not empty. If q1 is empty, stack is empty. That's all. This is the program. Let's run the code now. Okay, there is an error here. q1 dot remove. Okay, the method remove should have this parenthesis. Yeah, let's run the code once again. As it passes the test cases, let's submit the code as it passes all the test cases. That's all.